Hello everyone. Welcome to this session about function orchestration in the world of serverless. So I'm hoping this is gonna be fun. So I'm gonna wait for a couple of seconds to double check my audio. I just need to hear myself, and that's gonna take like. Hello everyone. Okay, there you go. It takes like 20 to 30 seconds. There's a delay on the live stream, so I just wanted to make sure my sound goes through. Okay, good. Now that it works, I guess we can start with this thing. So the idea of this session isn't. I mean, this is going to be limited to Azure Functions. First off, I mean, the world of serverless is definitely not limited to Azure, but my experience is, sorry about it. So I will be looking from, no, give me a second here. Okay, excuse me. I had to get that through. Okay, so my experience is limited to Azure, so that's where I'm going to focus on this session. And we're not going to do an introduction about serverless or functions. This is going to be kind of a level 300 to 400 session where we will look into how to orchestrate multiple functions, especially if you have when you start developing serverless apps, you might very easily end up having hundreds of functions that you have, and then you kind of need to communicate between functions, and that is a problem. How is that a problem? The problem is that there's a lot of work involved that we need to develop and get running in order to be able to simply communicate the functions that we're developing, and that's actually not something that we want to focus. What we want to focus is essentially build the functionality itself, right? Whatever is going to be implemented as a part of the the content, the functionality of the function itself, not necessarily the heavy lifting of making all these various pieces talk to each other and manage the workflows between those pieces. That's something that ideally we don't want to do, and that's where the concept of orchestration comes in. You have all these functions and you want to orchestrate the workflows between those functions, and when you want to do that, you have actually two different options in Azure, and not necessarily in Azure, but overall on the Azure Functions stack, if that makes sense. So the first thing that we got is a very high level service, part of Azure, Azure PaaS, and it's called Azure Logic Apps. So Logic Apps are a piece of beauty. I mean, if you didn't look into Logic Apps, I strongly suggest you to spend some time doing some research, because it's not just don't take it from just a function orchestrator perspective. The aspect of Azure Logic Apps where there is tons of connectors to various cloud services out there, that really helps if you want to ship something really fast. I'm not going to say it's the cheapest option out there, and I'm not going to say it's something that you cannot do. I mean, you can definitely build out all of these, it's called connectors. You can definitely build out all of these pieces. But the idea is Azure Logic Apps has already all these connectors to services like Office 365, Salesforce, and tons of different services. And using Logic Apps sometimes is a good option if you want to leverage all these connectors and be able to get something out really fast. But again, I should really mention that Azure Logic Apps, compared to something that you're going to build yourself, isn't really cheap. But again, that's what happens if you if you don't do the work and you expect a product to do it, I guess. So the other option is durable functions. I didn't really explain how Azure Logic Apps does the orchestration. Azure Logic Apps integrates not only with third-party services but Azure functions as well. So it happens to be an environment where you can bring in all of the functions that you have and start building, workflows in an IDE in a visual manner. And that's really very helpful because you don't need to write any code. I mean, if you want, you can definitely do it because there's a workflow definition file behind every Azure Logic app. But the idea is that, in an ideal world, you shouldn't need to go into that workflow definition file. You should simply be able to do whatever you want on the designer surface. I'm not going to focus a lot into Logic Apps during this presentation. I mean, we will simply have a look at the end of the session to see what it is. But it's very easy to use, and it's a good option if you want to do orchestration, in a visual environment. Azure Durable Functions, on the other hand, is a full, hands-on coding environment where you kind of codify, code the workflow. You manage all of the, flows. You create the flows by writing, either C# or JavaScript. The last time I checked, those were the two that were supported with Durable Functions. Durable Functions itself is not a service. It's actually a NuGet package that you can download and add on top of your Azure Functions project. So it's not really, I might argue that it's not dependable on Azure, but it kind of is because Durable Functions is using Azure storage as the backing storage for a lot of the stuff that it does. With the version 2 of Azure Functions and then the latest version of Durable Functions, the storage subsystem is pluggable, it's modular, so there are discussions about building Redis providers and maybe other providers as well. The project and the runtime itself is it's open source on GitHub, so that's totally up to the community, but the extensibility is available with the latest version. So that's good to know. If you want to move over to another provider, you can definitely do that. Long story short, if you look at Azure Logic Apps, it's a hosted service, and Azure Durable Functions is simply a NuGet package. So that is a big difference between the two, or how the two are being delivered. So we're going to focus on Durable Functions during this session. And I just wanted to include some of my notes into the slides so that at the end of the session I will be sharing the slide deck with you so that you can have some of the notes as well and take it with you. So when we look at Durable Functions, first off, the biggest feature, the highlight is the fact that you can start building stateful functions. The state is managed by the Durable runtime. It manages the state, it creates its own checkpoints, it manages the checkpoints, it restarts when needed, it replays. We will have demos and look into the details of this, but overall, you can start building stateful stuff and not really worry about how it is being stored, persisted, and so on and so forth. You can have, the beauty is that you can have stateful workflows, which are going to be implemented as orchestrator functions. So orchestration itself will be implemented as an individual function, and that function we will call it an orchestrator function. Its responsibility will be to orchestrate all the other functions that you got in a project, and these other functions will be doing the actual work that you want to do. So that's going to be kind of the high level concept. And when we say workflows, of course, when you're looking from the Durable Functions window, there are no JSON schemas, there are no designers, none of them are needed. If you need any of those, that's Logic Apps that you should look into. If you're looking into Durable Functions, those things do not exist. The workflows are actually pieces of code that call other functions synchronously or asynchronously. They get the output from these functions and decide on what to do next. And during that workflow process, the state between every activity is actually being snapshot and stored by the durable functions runtime, so you don't need to worry about that. The checkpointing happens automatically. Checkpoints are being saved into Azure storage. The implementation of the functionality, I mean, I will go through the C# implementation of durable functions. And when you look at the C# code, I mean, this is going to be very familiar to those of you who have some experience with TPL, the task parallel library, or simply, if you used async await in C#, that's been there for a long time now. If you use that, that's gonna, the whole durable functions thing will look very familiar. But instead of managing threads and threads and thread pools, what we will be doing is to manage, the life cycle of various functions with the async await keywords. Okay, so the first scenario that we got to go through is a simple one. In this case, what we have is a bunch of functions that are going to, run sequentially. Let's say your first function is supposed to do something, and then you output. You have to hand it over to another function, and then to another, and then to another. Just because you want to have different scalability, options on all these operations. And this isn't something new. This is something that we have been doing, like. Even if you consider from an Azure perspective, this is something 10 years ago that we could do with simply worker roles plus queues between all of those worker roles, and we could scale every worker role separately. So this has been something that we have been doing for more than 10 years on Azure. But the thing is, you gotta do all the heavy lifting, which means you gotta put a job into the queue, and then another worker role or a process has to listen or do polling, or whatever, listen to the queue, and when there's a new job, it needs to take it over, process it, and put it in another queue. And this is a lot of work, especially if you consider the fact that on function 3 you can have an error, and you're gonna even roll back function 2 and 1 if there's an error on function 3. That really can get really messy very, very easily. So and there is no, I know that the relationship between all of these pieces and the queues are, there's no way to really manage those from a single environment. Single code piece, because those are all spread out. The implementation of all these communication functions, they're actually spread out across all of the functions. And there's a lot of overhead about the detail and error handling. So how can we do this if we wanted to do it with durable functions, right? So let me go to my desktop here. I'm going to start from scratch because we're not going to do a 101 about Azure functions, but I still wanted to start from scratch to show you how easy it is to start. So I will be creating an Azure Functions project here. Click Next. Give it a name, click Next. So this is going to be an empty functions project. Let me create that. And this is going to take a while. And meanwhile, if you have any questions, there's a section. There should be a section. Hopefully, there is. Oh, it looks like I forget to enable that. Okay, you can, oh yeah. It looks like I forget to enable Q&A. So if you have any questions in that case, send me a tweet. Yeah, I will make sure I monitor Twitter right now. Send me a tweet or a direct message on Twitter, and I will make sure I answer your questions here during the session. Sorry about that. It looks like I forget to enable Q&A for this session. So I got Visual Studio here. I have my empty Azure function. The first thing I'm going to do is to right-click and start, building some functions, right? And when I say add new Azure function, I will have the screen where I'm going to give it a name. I will call it Orchestrator, or let's say Orchestration sample. Okay, and add. So now we're going to have a list of templates that we can use. One template that can be really helpful to start with is this one. durable functions orchestration. This template comes with a bunch of code that we will be using for pretty much all of my demos here, and this is a very good starting point. So I will click OK. This is going to add a new file into our project that is going to have 3 different functions. I mean, yeah, this isn't ideal, to be honest. When I do development with functions, I try to keep every function in a separate physical C# file. But I guess just for the sake of this templating, to make it easy, they kind of included 3 functions. Actually included 3 functions into the same file, so that's okay. So just so you know, again, I mean, there are 3 Azure functions in this file right now. Where we're going to start from is this one, the last one. So this one, again, in case you don't know about Azure functions, this one is actually a function that has an HTTP endpoint. And this is how we define an HTTP endpoint for a function. It has an HTTP request message as a parameter, and the parameter has a metadata attached to it that says HTTP trigger authorization is anonymous, and you can then come to this endpoint with a GET or a POST request. So this is what defines an HTTP endpoint for this particular function. The name of the function is not important. This meta attribute here for the method is important because that's how you convert this C# function into an Azure function. And the name here is the name of this Azure function, right, for the runtime, for the Azure Functions runtime. So this is the method name, this is the function name. So at that point, this is pretty much all Azure Functions stuff. What converts this into actually this. Okay, here, let me start from here, from this line, because this is an entry point. This is not necessarily an orchestrator, right? But this is an entry point that is going to start our orchestrator. So in this case, in this HTTP API, I mean, we can even call it an HTTP API. What we're doing is we're using this durable orchestration client that is injected into this function because it has the durable client attribute and the parameter. So we are using that. We're talking to the durable functions runtime and starting a new orchestrator that is named orchestration simple. And we're passing no parameters to orchestrator for now, but starting an instance of it. So this is important because, I mean, the orchestrator itself is implemented up here. So this is the orchestrator. This one is a way to start an instance of an orchestrator. So the orchestrator will be using other functions to accomplish the job, right? And we're going to have tens of, hundreds of functions, and all these functions will be, orchestrated by the orchestrator function. And someone has to start the orchestrator, right? And you can have multiple instances of the orchestrator. You can have multiple instances of a workflow, right? So in this case, we got an HTTP API that we're going to call to start an instance of the orchestrator. We will get the instance name back, and that's going to be all. At this point, I mean, there's an await comment here, but keep in mind that we are simply starting the orchestrator. Once it's started, it's going to keep running itself. We're not going to wait for it to complete. What we're waiting here is simply the completion of the starting, right? Once the orchestrator starts, we will get the instance ID back, and then we're calling another method on the orchestration client, which is called create check status response. To this, we're passing 2 parameters. The first one is the HTTP request message of this API, so that this method can output the response into it. And then finally, we are passing the instance ID of our orchestrator so that this method can create the appropriate response, status response, report for this particular orchestrator, and we will return that. So this is an API call. We will hit this up on HTTP. We will hit this up on Fiddler, and this is going to start an orchestrator and report us back with a particular response. So this is all that this is going to do. Let's go a little up and look at this particular function. So this particular function is a pretty simple one. It has a string parameter, and it returns a string. So in this case, simply we're, if you say Darren, it's going to return saying hello to Darren and return hello Darren. So this is logging. Sorry about that. And this is logging, and this is what we return back. So this is kind of a hello world type of function. This function is an activity trigger. Has an activity trigger, which means this is for the durable runtime. This is a function that is going to do some heavy lifting. This is going to do the work, right? This is going to process images. This is going to process text. This is going to, talk to third-party endpoints if you want to talk to. This is going to do, AI stuff. I mean, whatever you want to do. The work is going to be implemented into activity functions. You can have, again, you can have tens of thousands of this, as many as you want. Those are the things, those are the little pieces that we will be orchestrating by the orchestrator function. So in this case, this is again getting a string and returning a string. That's all it does right now. Up here, and this is the final function that we will look into, that we have another function that returns a list of string. The name of the function isn't important. Sorry, the name of the method is not important. The name of the C# function is not important, but the Azure function name is here. It's not important either, but this is the name we used when we, start an instance of this orchestrator. So that's the name that we use down here. So it's important that we use the same name. We can have multiple orchestrators, multiple instances of the same orchestrator, or multiple orchestrators. That's totally up to you. So this orchestrator, this Azure function is actually an orchestrator because it has an orchestration trigger. So the orchestration trigger gives us the orchestration context, and we use it to do orchestration, which means we use it to call other activities. So within this orchestration function, in this case, what we're doing is we're creating a list of string, and then we are calling the orchestration sample hello function that was just down here, the hello world function. We're calling it giving 3 different parameters. And every time we call the call activity as sync, we're passing a string and we're expecting a string back, right? And every time we call it, we get a task back out of this one, and we await the task. Once we got the string back from this activity, which is going to be, hello Seattle or something like that. Once we get it back, we will put it into the generic list. We will keep doing it sequentially 3 times, and finally return the generic list back. And you might wonder, hey, what's going to happen with this, output, returning the output? Because, when we called the API, we didn't wait for the completion of the orchestrator. There's no way we can get that data back. What's going to happen with this one? We will see. We will see. I mean, what we're going to do when we run this thing, you're going to see where it's going to come out. So the one important thing here is that we're running these sequentially. We will call it, wait it, call it, wait it, call it, wait it. But what's important here is to understand that the waiting, when the waiting starts, when we call these functions, the orchestrator itself will be snapshot. What does that mean? I mean, the state of this orchestrator will be saved, and the orchestrator will be killed. The next time when this for example, when this activity is completed, the orchestrator will be relaunched. It will replay. The output of this task will be included. It's not going to run again. It will be included. It will continue running. The orchestrator will continue running, and the second activity will be called. Then the orchestrator will die again. It will be snapshot while this activity itself runs. Right when the output, is returned, this orchestrator will come alive again. It will replay. It will start from the top again for every task that has been completed. The results will be injected. And then if there's a task that's not completed, that task will be executed. And while we wait for it, again, the orchestrator will die, and so on and so forth. So if we look at this, what's going to happen is orchestrator will run till here, right? This is the first run of the orchestrator. The function will be called. When the function returns, the orchestrator will run again. This is going to be the second playback of the function. It will come here. It will, inject the result. It will continue, and here it's going to run another function. Actually, the same function with a different parameter. And this is going to be the second run of this orchestrator, second replay. It will be killed, right? It will be snapshot. When the activity trigger returns its response, it's going to start from scratch again. It will come here, fill the content from the old state, fill the content from the return of that activity. This is going to be the third run, and this time it's going to need to call this function, which means the orchestrator will be snapshot again. When the function is complete, there's going to be the fourth run for the orchestrator. It will start from the beginning. It will go and fill all of the content from the previous snapshot. It will get the result from this one, and finally it will return the output, which means for this code, if you run this one, if you look into your logs, you're going to see 4 playbacks of this orchestrator. So the very important thing here is that, not to do any heavy lifting within the orchestrator itself, because keep in mind, during every, replay, we will actually be executing this line of code. For example, during every replay, this variable, this collection, this generic list will be initialized. So it's not, it's not a lot to initialize a generic list compared to, for example, if you did some, download or something. So if you're going to download something, if you're going to download a CSV file to be processed, for example, that shouldn't be done in the orchestrator, because if you do that, during every replay, you will re-download everything from scratch. If you're going to download a CSV file and process, it needs to be part of an activity trigger so that during the await process, the snapshotting of the orchestrator and resuming of the orchestrator doesn't affect, right? The states are saved. So long story short, when we say the states are saved, actually we're saving the state of the tasks, not necessarily the state of the task, but the result of the tasks. So if you do something within the orchestrator, it's not going to be saved unless it's an activity. So that's very important, because otherwise, the time that you spend, the time that you start running the orchestrator can be really costly, because it will simply replay and redo everything from scratch if it's not an activity, if it's not saved as a part of the snapshot. Okay, yeah. Let's run this one and see if it really works, right? Okay, we will have simply a single HTTP endpoint that we can call, because all of other functions are not exposed through the HTTP layer. Okay, I guess I got that. There we go. So let me open Fiddler and send a request. And when we do that, let me put a breakpoint here and a breakpoint for the activity trigger as well. And here we go. Send a GET request. Good. We got 202. And here we go. The orchestrator has now kicked. So let's go with F10 step by step, right? So we'll hit F10. This is where we're going to start our first activity instance. We will call the activity down here, passing Tokyo as the parameter, F10. Here we go. Activity is ran. Cool. Let's return back F10 and F10. Here we go. The orchestrator will rerun again. This is the second run of the orchestrator, because we just returned a value from the first activity here. The task has been completed, so the orchestrator runs again. We will initialize the variable again, but this time when I hit F10 right now, this activity will not run because we already got the result from it. Okay, so when I hit F10, you will see that this breakpoint in the activity will not be hit, but we will simply jump into the second task down here. And I'm hitting F10. There we go. We're on line 2, line 22 here. So this task didn't run yet. So when I hit F10, we will jump into the activity trigger, F10, and here we go. We're in the activity trigger. This time, the parameter that we got is Seattle. Cool. Let's say hello to Seattle, F10, F10, and the orchestrator started from scratch, right? Here we are. F10, initialize variable, first task has been already completed. I mean, in case you don't see right now, let me zoom in. So the collection right now is empty because we initialized this again and again. The state in this variable is not snapshot. What snapshot is the result that comes from these tasks. This task has been ran, the content was snapshot, the result was snapshot, was part of the state. So we will not, the runtime will not run this again when I hit F10. But when we go into our collection, we will see that we got the output, right? We got the first result. So I will hit F10 again, and it's not going to run the activity because we did already run that. And when I look into my collection, there are 2 items in here. When I hit F10 again, this time it will run the activity because this is the first time we are running this particular task, right? So let me hit F10 again, and another F10, F10. And here we go. The orchestrator starts from scratch. Again, I zoom in, there's nothing in it. F10, 0 count, F10, the activity didn't run, but I got 1 count. The activity didn't run, I got 2. The activity didn't run, I got 3. So this time, because I had the results of all these tasks already, calculated, I was able to go through all the lines without hitting the, executing this particular function. And finally, I can output the result. So I will hit F5 and we are done. So one other thing important to understand is that, these are functions, which means even though you see them in the same C# file, they happen to be compiled in the same, DLL, the binary. These functions do not have to be living on the same server. They are going to be, scaling. They will be on different pieces. So what I'm trying to say is the communication with these functions is not within the sandbox of a process or something. Those are living in different environments. So what's happening is that, the communication between those 2 pieces is being handled by the durable runtime by the use of the Azure storage. So, okay, let's go back to Fiddler and remember this was an HTTP endpoint where we were returning some kind of a response. Let's see what we got out of this. Let me switch to, oops, just a second, JSON. And when we zoom in, you're going to see that we got the orchestrator instance ID, excuse me. We got a couple of methods that we can call, and those methods are exposed by endpoints here, HTTP endpoints that are custom to our orchestrator. They include all the endpoints, include the orchestrator instance ID. We will look into some of those, but the status API is a good one to look into. Let's copy that and let's send a GET request to that one. Let me send a GET request to that one. So I did send a GET request to the status API. Let's see what we got out of it, and here you go. So we got the final status of the orchestrator, which is completed, and then we got the output. So you can always query this. If you had an orchestrator that was running for a long time, you would obviously get a different status, not completed. And then we got the output of the orchestrator's, return variable. So this isn't actually a place to save, the resulting work of the orchestrator. If you're gonna, for example, create a PDF file or something, that should be done in an activity trigger first off, and the activity trigger obviously should save it into a blob, or if you're going to save something, save it into the database. I mean, this isn't somewhere to, to store the end result of whatever work that you are going to do. Just keep that in mind. Okay, let's stop this one and go back to our presentation. So just in case, I like to include the codes that I use into the slide decks as well, in case you need to take a look into those. Those are included in the slides. The second scenario is the fan-out, fan-in scenario. In this case, one of the functions, for example, can create multiple jobs out of whatever work it's doing, right? For example, if you got a shopping cart, if you got an order, the first function might be processing the order and then creating, individual tasks for every item in the shopping basket, right? The order can have multiple products. And that's where you end up putting multiple jobs out of a single one that you already processed, and then another function has to process all these jobs, and that means it has to scale up. And the scaling will happen obviously automatically and transparently in the case of Azure Functions. But how do we manage all this through durable functions? How do we manage the process? Because one of the difficulties here is that going from F2 to F3, which means you got 5 different instances of a function, and then you don't want to run function 3 without making sure all of these 5 instances have successfully completed, right? I mean, this kind of resembles to a scenario where you, for example, have 5 different HTTP endpoints that you have to hit, and you want to make sure you can hit them in parallel. And continue with your code when you got responses from all these 5 endpoints. I mean, that's kind of something that can sound easy for a client-side app, but on the server side, you cannot keep people waiting for it, right? That needs to happen on the background. And if those are individual and independent pieces, because you don't know, I mean, you might be able to process a single product very easy, but the other product might require more processing. So even if it sounds like those are all identical instances of the same piece of code, there's no guarantee they're going to be completed in the same amount of time. Some can take longer amount of time, so on and so forth. So it's really not very easy to make sure all of these operations are completed, and then you can go on with your final piece of code that you got on function 3. So how can we do that? Let me jump back to our code here. Remove the breakpoints. So I will simply copy paste some code that I already have in here. It's pretty easy, nothing extraordinary. Here we go. So in this case, and I gotta change those as well. There we go. So in this case, what we have, the main difference but between the code that I just passed it and the previous code that we had on the screen is that we don't have a wait here. We are calling activities and not waiting for them to complete. We're calling all of them in parallel, like in a fire and forget fashion. And finally, here you see that we are using task when all. I mean, this is something that we're familiar with when we're using regular TPL, and by regular TPL I mean the TPL that is used to manage threads. But in this case, we are actually calling different instances of the same function that might be living on different servers, right? When we really scale this thing out, when it scales, right? So and the code is really very, very easy. Like there's no detail about the implementation of how you can make sure that all the 3 instances of these are being returned before you can resume your orchestration function. Let's put a debug point here, or maybe here, and run this one. And let's see how that really works. Okay, let me look at Twitter, by the way. Do I have any direct messages and questions there? It looks like I don't. Okay, that's good. Cool. So we got this running in here. Let me copy the endpoint and hit that one. There we go. We are kicking off the orchestrator, and here we got the breakpoint. So in this case, I will keep going with F10. Obviously, we will run all of the activities, and let me put a debug point here as well, so that we know when the activities is running. Another F10, Here we go. And we will start waiting for all the three, right? This is the first run of the orchestrator. I will hit F10. Orchestrator is now dead. All right, orchestrator is not running anymore. It's killed. It's snapshot. So the activity trigger has ran. Let's look at the parameter. This time it's for Seattle. Cool. F10. Wow. Okay, I got another one. This time it's for Tokyo. Cool. F10. I guess this is Seattle. We are back on the Seattle instance of this activity. F10. This time I'm on London. This time I'm on Tokyo and Seattle and Tokyo and London. So during all this time, we are going through, different lines of 3 different instances of this activity trigger. And while all that happened, notice that we didn't hit the debug point that I had set up on this, on the top line of this orchestration trigger. So the orchestrator didn't run so far. It did run only once until this point, and it didn't run again. But the 3 instances of the activity trigger, they actually got completed. So I will keep hitting F10. And at one point, okay, the orchestrator replay is happening because all 3 instances of the activity trigger are now completed. Let's hit F10. The output variable is being initialized from scratch. Cool. Let's look into that. We got 3 items in there. So the return values have been populated, and now we can continue, right? And we can return the generic list back. I will simply hit F5 to complete that. So this is a very easy use of running, asynchronously multiple functions. You can have as many as you want, and you can, fan out. And then once the fan out is completed, once you got all of the results from all these functions that you had to run during the fan out process, you can fan in simply saying task went all, and that's as easy as that. Isn't that cool? Yeah, I think it is. So the other scenario that we gotta talk about is the eternal process scenario, where you have an orchestrator client that is going to run forever. So the state of the orchestrator is being always snapshotted, right? So it doesn't need to die. The orchestrator can keep working forever because when it is waiting for something, the orchestrator itself is not running. So it's not costing us to keep the orchestrator alive, because it is actually not alive. It's being snapshotted into the storage. So we are not paying additional amount for the compute or the processor to keep the orchestrator alive, because again, it's not alive. And for this, obviously, you can keep doing the work, going and checking stuff and so on and so forth. But another interesting aspect of the durable functions runtime is the fact that you can actually have external events, trigger actions, and include it within the workflow, right? And that's what makes the whole thing a little bit more interesting. So let's look into that. So here, again, I'm gonna simply copy some code that I already have here. I will change this part of the code. I will leave the upper section as it is. And here we go. So in this case, what we have is, let me stop the project first. Okay. And include some using statements. Okay, cool. So in this case, on top of what we already have up here, we are adding a second functionality. What we have here is that we got 2 different constraints. The scenario is that we're going to wait for a text message validation. Imagine, a login scenario or something like that, or an event that you have to wait, an external event that you have to wait, but it has to have some kind of a timeout as well. It can be, in this case, it's 20 seconds up here. I will make it 60, but it can be days. without, you can take your orchestrator into sleep, into hibernation, essentially, by saving its state and wait for an external event and implement a timeout. I mean, usually this isn't something as straightforward as it looks here to implement, but let's look into the code right now. So what we have here is actually, again, two different tasks. We're creating two different tasks, and we're waiting any of them to happen, right? Any of them to complete. The first task that we have is a timeout task. We are creating a timer. It is very important to create a timer from the context here, which is actually the orchestration context, right? So we get the timer from the orchestration context, we give a timestamp, an expiration time, and then we are giving the cancellation token. Another important detail here is that the expiration time itself, the timestamp itself, has to be requested from the context. Because obviously with every replay, the time will shift, and we don't want to always postpone the expiry time, right? So if we get the current UTC date time from the context, it will make sure we get the original time where this orchestrator has started, because at the end of the day, this code will run again and again with every replay, and we don't want to get an up-to-date start time shifted. So that's important. Timer getting from the context is important. And the second task is another one that we get from this method called wait for external event. This is again a method of the orchestration context. This is how we create external event endpoints. In this case, the name of the event is text message challenge response, and we're expecting an integer to be passed to this event. This actually can be a complex object. You will see we will hit this endpoint. There's going to be an endpoint where we will pass on this event through an HTTP post. During the HTTP post, in this case, we will simply pass an integer in the body, but we could have used a complex JSON object, and it would be deserialized into a complex type if we had one in here as into this generic definition. And finally, once the two tasks are defined, then we have tasks that when any and waiting for it, either the timeout will happen or the event will kick in, so we will know who is the winner and act accordingly. Cool. So let me run this one and see how we can, kick the external event. I will put a debug point here so that we know when we hit that one. Okay, I guess we're up and running. Let's start a new orchestrator. Cool, it's coming up. Great, let's remove the debug point there. Okay, where are we? Okay. There we are. Okay, great. So I will hit F10. We will create the two tasks, and then finally we will start waiting for it. So we got 60 seconds. Meanwhile, let's look into the response of our status report when we first created this orchestrator. What we got here is another URL, which is called send event post URL. Let's copy that and look into the URL into a little bit more details. So let me look at this one. So this is the endpoint that we gotta hit to pass an event, an external event. This comes with the durable runtime. It has the instance name ID of the orchestrator, and then it asks for the event name. In our case, it's the challenge response. So let me go back and put that in. And this is where we're gonna hit. Let's go to Fiddler. Right now, no one won the race. The timeout was 60 seconds. Hopefully I will be faster than that. I will do a post, and in the request body, I will pass simply 2 as the integer and execute. And I got a 400. Why do I have a 400? That's bad. Okay. Triple task instances. Okay, I guess the timeout kicked in. Let's see. This is another scenario to be tested, right? The winner is the winner is the timeout. So the timeout has been completed. We gotta run this again. Let me stop that for a second. Instead of 60 seconds, maybe we should do 120 to make sure I can make it in time. Let's run that. Let's repeat this one to start a new instance of the orchestrator. There we go. Come on. Okay. Response. Here we go. Send event, copy. Oh, this is the endpoint. This is the challenge. Name of the event. Let's copy that one, and this time into the composer, I will pass that, see post. Oh, now I remember what I forgot. Content type, application, JSON. There we go. Oh, I guess this was the issue. And yes, here we go. I did hit the event, the external event. When we look into there, we're going to see that the timeout isn't completed. And when we look into the winner, you will see that the result is 2, which means the integer that we passed is now here. So this is how you can interact with an orchestrator. I mean, if you had a 2 days long, interval here, I mean, you can actually, let's say you don't have a timeout at all. This orchestrator will be saved forever until you hit the external event, right? So you can have long-living orchestrators that can live forever, right? And you're not going to pay for it because it's not using compute. It's simply stored, snapshot into your Azure storage. Obviously, you will pay for the storage, but the state, the size of the state is very small. So, and you can, kick the external event whenever you want to, take it alive and continue the process, continue the workflow whenever you want. So that kind of might sound like a little bit like an actor implementation, and it actually is. And there's an actor implementation on top of durable functions that I'm not going to go into for now. It's not part of the this particular session that I planned for. But know that there is a separate actor implementation that you might want to look into that, and that might be really useful too. So this is the code that we used to make things happen, just in case. And okay, that's it with the durable functions for now. So what about logic apps? So again, logic apps help you save time. By designing everything on a UI instead of coding and maintaining the code, essentially. So there is no maintenance that you have to do about a logic app; it just runs. And there's a huge amount of connectors that you can use. And one of the advantages of logic apps is that because it doesn't require coding skills. Someone with no experience of development can actually go into a logic app and modify the workflows. I mean, it might be a nice thing or a bad thing that totally depends to the scenario, I guess. So let's look into that. How does a logic app look? I mean, this particular logic app, I don't know, for some reason it's not working today. I mean, this has been a logic app that I used for demo purposes for a long time. It was working. I don't know why it's not working. There's some weird stuff going on here. I have to maybe submit a support ticket to you, to the team there. But let's look into that. Let's look into this logic app and try to understand what it's accomplishing. So in this case, I mean, you got these boxes that we can drill down. I mean, you can add as many activities as you want here. Those are all drag and drop type of thing. You can add an action. I mean, I'm not going to go through the whole concept of logic apps, but the important thing to understand here is that there's a lot of connectors that you can use as well. For example, if I search for mail, there are Office 365 connectors and actions. For example, if you want to create a contact and then particular Outlook account, I mean, you don't need to worry about, what Graph API to use, how to authenticate, and so on and so forth. Everything is already implemented there through connectors. So you can definitely include those. In this case, what we are doing is that we got an HTTP endpoint that we can hit. We are sending a list of images. The list of images are being parsed into a JSON. Then I am defining another, array. And then we are looping through a for each in loop through the list of images that we got. And for every image, we're calling an Azure function, passing the current item, the URL of the image. And this Azure function is actually calling and running an AI model that is looking into the image and saying if there's a food in the image or not, as simple as that, true or false. And we are getting the output from this function, running a condition. If there is food, then we are adding the item into our, array that we just initialized here on the upper box. And if it's not food, then simply we are doing nothing because we don't need that. And finally, we are, returning the list of array that we just, populated with only images that had food in it. Into the response. So this is kind of very, very simple logic app, but it shows, how you can implement, if conditions, how you can implement for loops, how you can parse content, create variables, and call an Azure function. In this case, this one has a single Azure function, but imagine you had multiple Azure functions. You can call an Azure function after the true statement. You can call another one after the false statement. We're calling a single Azure function as a for each loop. So essentially, the idea is that you can have your functions. They don't need to be activity triggers in this case because there is no durable function, orchestrator or anything like that. The orchestrator in this case is the logic apps. And if I want to, for example, add a function in here, what I need to do is to, add a box, call for, search for function. Click Azure Functions. It's going to list all of the Azure Function apps that I got in my subscription. And when I select the function app, it shows, what function exists in the function app. And I select my function, and here we go. I have to pass in the parameter for its body, and then on the next box, I will actually get the output of this function. That's it. That's how you can add, as many functions as you want into this and create workflows visually in the design. If you want to go, you can definitely go into the code view, and this is how this workflow is defined. But this isn't the idea of logic apps, right? I mean, you shouldn't need to modify that code file. This is where you should work. And this is how you can use logic apps to orchestrate your functions. You can even go with a mix of the two approaches, which means you can actually add orchestrators into logic apps, which means orchestrator themselves or functions, right? So you can have a logic app that can orchestrate orchestrators. I mean, I can't imagine why would you want to do that, but that's something you can do, right? I mean, you can have, if you have multiple orchestrators flows that have to be coded, and then you still want to have to expose some kind of a designer UI for the high level workflow. You can definitely do that as well. Yep. So this is simply a screenshot of what I showed in there, and here we go. This is the end of our session where I want to share some of these resources that might be valuable for you. The workflow definition stuff that I just showed you, if you want to look into the details of it, there is a link there where you can access the definition language schema. And then the durable task framework is something that you might want to look into. And finally, the link for the NuGet package for durable functions. And if you download the runtime and install it on top of Visual Studio, you might not need to worry about it. I mean, if you add a orchestrator file through the IDE, it does add the durable functions NuGet package automatically. You don't need to do anything about it. But still, I just wanted to put the link out there so that you have access to it. And yeah, that's pretty much it. This is the address where you can download the slide decks. Let me look into Twitter right now. Okay, it looks like there are no questions. I don't see anything on Twitter for now. Yeah, let me know if you have any questions on Twitter. Hit me up there. I will be more than happy to help you out. And hopefully this was a helpful session. And enjoy the rest of your day. Thanks.